I'm going to go over the 12.5 homework solution, starting with number 26. And number 26, we're given standard form, and we need to work from that. We could try factoring this, but just looking at the way you're going to have to multiply 5 times 123 and try to work through this. Factoring is not going to be the way to go, and it may not even factor. So I'm going to pick up with the method of completing the square. And that method is you take a look and just kind of separate or put parentheses around the term with the x squared, which we call the quadratic term, and the term with the x, which we call the linear term. And then the second step is to factor out a from that. A is the number in front of x squared, so factor out the 5. This is different than factoring out the greatest common factor, because the greatest common factor would actually be 5x. You want to leave the x in there. So what's left is going to be x squared plus 4x. I'll leave a little room, and then you got that plus 123 at the end. Then the next step after that is to find out what positive b over 2 squared is. B over 2 squared, so half of b squared. B is the number in front of x, inside the parentheses in this case, so it would be 4 for us. And so I substitute in 4 for b, and that gives me 2 squared, which is 4. And that's the number that we're going to add, but that wasn't part of the equation, so we're going to have to also subtract, because 4 minus 4 is 0, and 0 doesn't change any value. We're just changing the way it looks. After that process, or after that step, we have 4 terms inside of the parentheses, and we're going to get rid of that 4th term by multiplying 5 times negative 4, which is negative 20, to move that negative 4 term outside of the parentheses. And now we're left with y is 5 times x squared plus 4x plus 4 minus 20. That 20 came from 5 times negative 4 plus 123. Now what's left inside of the parentheses, the x squared plus 4x plus 4, is something that will factor. And not only will it factor, but it'll factor to a perfect square. And that's why we call this process completing the square, because we actually are able to get something factored to a perfect square. I'm going to do that factoring process over here. We got the x squared plus 4x plus 4, and we're factoring this. So we're looking for 2 terms that multiply to 4x squared and add to 4x. 2x times 2x, that's what we're going to use. And factor by grouping. And we end up with x plus 2 times x plus 2, which is a perfect square. It's x plus 2 squared. And so that we can further simplify this to 5 times, not simplify, but further bring this into vertex form by factoring, and we get 5 times x plus 2 squared plus 103. And that is going to be my vertex form. So y is 5 times x plus 2 squared plus 103. And we quickly get the vertex from vertex form. You have the x plus 2 inside the parentheses, so you're going to grab the opposite of that, which is negative 2. You have the plus 103, which keeps its sign, so the positive 103. So negative 2, 103 will be our vertex. Our y-intercept's pretty easy to get. You just plug in 0 into one of the equations It's easiest to plug it into standard form because when you do, the quadratic and the linear terms both zero out, and you're left with a constant, or we call it C, which in this case is the 123. So if I plug in 0 for x, I get 123 for y. To find the x-intercepts, you got to plug 0 into some equation and solve. In this case, I'm going to plug in 0 into vertex form because I don't have a factored form yet, and it's easier to work with vertex form than standard form. And I'm going to solve this by subtracting 103 first. And then dividing by 5. I'm going to switch sides here. Take the square root of both sides. So when you take the square root of the left side, I forgot my square, the square and the square root will, in a sense, cancel each other out. And when you take the square root of a fraction, you can take the square root of the top and the square root of the bottom separately or together. I'm going to do them separately. And don't forget, it could be positive or negative, and that plus or minus sign needs to be outside of the square root sign. So now we have x plus 2 is equal to plus or minus the square root of 103, or negative 103, over square root of 5. Now we're going to need to simplify this a little bit further. A couple things here. We can't have a square root in the denominator, so I'm going to multiply the top and the bottom by square root of 5. And I'm going to continue on down here. And I get x plus 2 is equal to plus or minus, I'm going to pull the negative out of that square root of 103, and that becomes our imaginary number. 103 times 5, I forgot to do that, sorry. I'll just put times square root of 5 here over 5. Alright, almost there. I'm going to now subtract 2 from both sides. Multiply the 103 and the 5 together. And that could be your x-intercept, or you can make it one fraction. I will make it one fraction right now. So you got 2 over 1, since I can't reduce the other fraction. So I'll multiply top and bottom by 5. And I get x is equal to negative 10 over 5 plus or minus I square root of 515 over 5. Alright, almost there. Negative 10 plus or minus I square root of 515 all over 5. Okay. So if I were to ask you for the roots or the zeros, that's what you would end up with. But this is where an x-intercept starts to become something different than a root and a 0. A root and a 0, you can work with real numbers, you can also work with imaginary numbers. But x-intercepts only work with the real numbers. So if you end up trying to find an x-intercept and figure out that you're going to end up with an imaginary number. So probably I'll circle it here. At this stage, or you could even be before that, I'm going to detect, hey, I'm going to be taking the square root of a negative. And if I take the square root of a negative, I get imaginary. And if I have imaginary, I don't get x-intercepts. So I didn't have to do all of this work. I'm doing it just to show you what you should do if you found the roots or the zeros. You would have to go through all that. But if I'm asking you for the x-intercept, once you realize that you get imaginary answers, you could just say I don't have any x-intercepts. Alright, so we have our y-intercept, we have our vertex. Our axis of symmetry is the x value of the vertex. We know, I'm just going to make a note here, that this graph is going to open up since A is positive. And I'm going to start to graph what we have here. So -2 is going to be kind of the halfway point here. It's opening up. I'm just going to put an arbitrary vertex here at -2, and I'm just going to say the height's 103. I'm not going to take the time to mark that y-axis. I'm just going to say that that's what the height is. And then somewhere above it here, I'm going to label that as 0, 123. And if I use the idea of symmetry here, I'm going to go 2 to the left of the vertex and put it the same height as that y-intercept. So that's going to be at -4, 123. And I got 3 points. The center point is going to, or the vertex is -2, 103. I also have -4, 123. And I have 0, 123. And that's all I get from the work that I do, because I don't have any x-intercepts to add into that. So we still need to find 2 more points, and if none of your work leads to those 2 points, you just pick an x value. Alright, so I'm going to fill in this. I'm going to do -3 and -1. I'll let x be -1 and plug it into one of your equations. I'll use vertex form. And here I end up with 5 times 1 squared plus 103, which is 5 plus 103, which is 108. So I'm going to put the 108 next to the -1. And I'll kind of mark where that point is, -1, 108. And if I use symmetry here, get another one at the same height at 108, same distance on the other side of the axis of symmetry. So that's going to be at -3, 108. And now I got my 5 points. Domain's all real numbers. I'm going to sketch this in here. Range is all y values greater than or equal to positive 103. It's decreasing when x is less than -2 on the left side of the graph, and increasing on the right side. So that's 26. On to number 28. Alright, on number 28, I'm going to again start by Completing the square, I'm going to just put it into vertex form. Put parentheses around the quadratic and the linear term here. Factor out a. Leave a little extra room. I'm going to take b, cut it in half, and square it. So b over 2 squared, which is negative 3 squared, which is positive 9. So then I add that and subtract that inside the parentheses. Got 4 terms inside the parentheses. I'm going to get rid of that fourth one by distributing a to it, and I end up with y is 3 times x squared minus 6x plus 9 minus 18 plus 21. And now we've created a trinomial, 3 terms inside the parentheses that will factor to a perfect square. That's why we call it completing the square. So I'm going to go ahead and factor that. So what 2 terms multiply to 9x squared and add to negative 6x, and that would be negative 3x and negative 3x. And we're going to end up with 2 factors, x minus 3 and x minus 3. But they're the same factor, and so you can simplify that to x minus 3 squared. So now we get vertex form. And we see that our vertex is positive 3 because we have x minus 3 inside the parentheses, and then another positive 3 which comes from the 3 at the end. The 3 has nothing to do with the first 3 in front, the a. There's just a lot of 3's in this problem. Y-intercept is going to be, well, if I plug in 0 for x, I get 21 for y. So 0, 21. Finding zeros here. Now remember, zeros can be imaginary, so I have to figure out exactly what this is, whether it's real or imaginary. I plug in 0 for y. And solve here. Take the square root. Don't forget plus or minus on the numerical side. And so we end up with x is 3 plus or minus the square root of negative 1. The square root of negative 1, though, is the same thing as I. And so we change it. We can't end with a negative square root. So 3 plus or minus I. So my zeros are x equals 3 plus I and x equals 3 minus I. And I'm going to take note here that there are no x-intercepts, which means this graph will not cross the x-axis. Okay. The axis of symmetry is x equals 3. X equals the x value of the vertex. Our graph is going to open up since a is positive. A is 3. And so let's graph what we have here. So here's our center. 3. And we're going to put our vertex at 3, 3. So 3, 3, about right there. Our y-intercept is way up here at 0, 21. We got another matching one over here at 6, 21. I'll put those in the chart. And I'm going to pick a couple other x values. I'm going to pick 4. I'm choosing 1 to the right of my vertex. So my vertex x value is 3. I'm going to go 1 to the right of it. The closer you are to your vertex, the easier that number will be to find. If I pick something like x equals 10, it would be way too hard, because if you try to graph that, you're going to get this big number, and it's not going to fit on the graph for one, and it'll be a lot of calculations. But you keep close to that vertex, it'll be easy and workable. So I'm going to plug that into vertex form. Sorry, I said x equals 4, not 3. And so what happens here is we get 3 times 1 squared plus 3, which is 3 plus 3, which is 6. So 4, 6. About right here. And we got a matching one at matching height at 2, 6. Domain is going to be all real numbers. Remember, that's all x values. The range is all y values bigger than or equal to height 3. It's increasing on the right half, so when x is greater than 3, and decreasing on the left half when x is less than 3. Alright, last one here, number 29. If your standard form is missing the linear term, which is the term with the x value, then your standard form is automatically in vertex form. Or vertex form and standard form are equivalent. I'm going to write it, it'll look a little different, but it's really the same thing. Instead of writing x squared, I'm writing x minus or x plus 0 squared, which is really just x squared. But I put it in that way so you can see where I'm going to get this vertex from, 0, negative 1. Axis of symmetry is going to be 0, x equals 0, which is your y-axis, which tells you that the vertex is actually going to be the same thing as the y-intercept. If I were to plug in 0 for x, I get negative 1 for y. We need to look for the x-intercepts here. Plug in 0 for y. I'm going to add 1 to both sides. Divide by negative 4. Switch sides. Take the square root of both sides, and you get x is plus or minus square root of negative 1 over the square root of 4. Notice when I had this fraction, I could put the negative wherever I chose. I could have put it with the negative 1 or the negative 4. So I'm thinking ahead, and I know I want, it would be a little more complicated if I made the 4 negative, because you have the choice. And so I made the 1 negative, because I'm thinking ahead, and what's my next step going to be. So here we end up with positive or negative I over 2, which really we didn't have to finish all that, because we're only looking for the x-intercepts, and once we realize this is going to be imaginary, we could stop and just say, hey, there are no x-intercepts. By the way, I haven't been doing this in the last two problems, but I probably should. No factored form. You're only going to get factored form when you get X-intercepts, and not just any kind of X-intercepts, but when you get X-intercepts that are rational numbers. So numbers that can be represented as fractions without the square root. If you end up getting square roots or imaginary numbers, you're not going to have X-intercepts, or so you're not going to have factored form. You could have X-intercepts, but you're not going to have factored form over the integers, and that's what we're used to doing. We're factoring over the integers. Alright, so we really don't have much to graph here. We only have 1 point. So if I do this, here's my X and Y axis. I know that the vertex is at 0, 1, sorry, 0, negative 1. And that's all I have. I know that this graph will open down because A is less than 0. In our case, A is negative 4. And I just need to pick some more points. So 0, negative 1, I'm going to pick x equals 1. Plug that in, I end up with y is negative 4 times 1 minus 1, which is negative 5. So 1, negative 5. I'll graph that. Matching point on the other side at negative 1, negative 5. And I'll pick one more value here. I'll pick x equals 2. And so we get y is negative 4 times 2 minus 1, which is going to be negative 9. So 2, negative 9, I'm going to plot that. Actually, I'm sorry. I somehow lost the squared here, so this is going to be more than that. Let me fix this. It is not going to be 2, negative 9. It's going to be y is negative 4 times 4 minus 1, so negative 16 minus 1, so negative 17. So I get 2, negative 17. Somewhere down here. And you got a matching one on the other side at negative 2, negative 17. So this thing's going to look like that. Alright, our domain is all real numbers. Range is all y values less than or equal to negative 1. It's increasing on the left side, so when x is less than 0, and decreasing on the right side when x is greater than 0. Alright, so those are your answers to your homework. I hope things are going well for you, and talk to you in the next video.